Hi folks, we're going to take a look at an example of solving a rational equation. So this is number 1 from the Unit 2 assignment. So here our strategy is going to be to clear out these denominators, and we're going to do that by multiplying both sides of the equation by the lowest common denominator between these three denominators. Now when you're looking for the lowest common denominator with respect to rational expressions, best thing to do is to factor first. And we see here that you can factor each one of these. When I talk about factoring, I'm not necessarily talking trinomials or third degree. It could even just be factoring out a common factor. So here, let's start with this first one. I can factor out a 3, so 3 times x plus 1. All right, minus 5. Here, factor out a 4, x minus 1. And here, factor out a 2, and I'm left with x plus 1. Okay, it's much easier to see here that I actually have a common factor between these two denominators. And if there's a common factor, I don't need to take it twice. All right, so let's take a look at the numerical factors first. I have 3, 4, and 2. So I know I'm going to need 12 to incorporate 3 and 4, but I don't need anything else because 12 also has a factor of 2 in it already included. So I'm going to be multiplying both sides by 12. That's going to allow me to get rid of all three numerical factors. And then let's take a look at the factors with variables in them. So I'm going to need an x plus 1. Okay, I'm going to need an x minus 1 from the second denominator. But I already have the x plus 1 from the previous denominator, so I don't need to take another factor of x plus 1. So I need to multiply both sides of the equation by 12 times x plus 1 times x minus 1. Now you notice here I'm not going to multiply this out, at least not yet, because it's much easier to do the reducing with this expression in factored form. All right, so here I need to do the same thing to the other side, multiply by 12 times x plus 1 times x minus 1. All right, so if we start on the left-hand side, I'm going to need to distribute this to both terms. And when I multiply this by the first term, I see the 12 and the 3 reduce to 4. The x plus 1s are going to reduce to 1, and I'm just left with x minus 1. Okay, and then of course times 7x. Okay, similarly here for the second multiplication, the 12 and the 4 reduce to 3. The x minus 1s cancel out, so I'm just left with an x plus 1, and then of course times 5. All right, so now let's do the other side of the equation. Again, the 12 and the 2 reduce to 6. Okay, the x plus 1s are going to reduce, so I'm left with the x minus 1 here, and then times 3x. And so what we've done is we've turned this rational equation into a polynomial equation. So let's see how easy it is to solve. So here I've got 4x times 7, so that's going to be 28x squared. And then I got negative 4 times 7x, so minus 28x. Here I've got negative 3x times 5, so minus 15x. And then negative 3 times 5, minus 15. And then on the other side of the equation, what do we have? 6x times 3x is 18x squared, and then negative 6 times 3x is minus 18x. Okay, so fairly simple equation to solve. So here, bring the 18x squared to the other side, so 28 minus 18 is 10x squared. Here, if I bring the 18x to the negative 18x, it would be plus 18x, so negative 15 plus 18 is 3, and then I've got negative 28 plus 3 is negative 25x. All right, and then lastly here, minus 15 equal to 0. All right, now before I try to solve this equation, let me factor out the 5 and divide it to both sides. Okay, so if I factor out a 5 here, I'm going to be left with 2x squared minus 5x minus 3 equals 0. So be sure you understand what I did here is I factored out a 5 and then I divided 5 to both sides of the equation. But since the other side of the equation is 0, 0 divided by 5 is still 0. Okay, so it's not that the 5 disappeared. I factored it out and then divided it to both sides of the equation. If you need to show that step to remind yourself of what's going on, then that's fine. All right. And here, this actually looks like it might be factorable because I have a 2 and a 3, which give me 6, and I need to get to 5. So I think this is going to factor nicely. So 2x and x. And here I'm going to do 2x times 3, and then x times 1. And I need negative 6 plus 1 is going to give me my negative 5. And of course, that's equal to 0. So from here, I can pretty much read off my answer. X can be equal to negative 1/2, or x can be equal to 3. All right, and there's the solution. And I can stick these into my equation to check if they're the correct answer. All right, or just stick it into Des. Well, I wouldn't use Desmos. I'd probably use Symbolab to check that these are indeed the solutions. All right, so just to recap here. Step number 1, I factored all the denominators, okay, because that makes determining the lowest common denominator easier. Once I have everything in factored form, I determined what the lowest common denominator was and multiplied it to both sides of the equation. That had the effect of canceling out all the denominators, so make sure you're doing this carefully. And then from this rational equation, I turn it into a polynomial equation. Now, just one thing you might want to check at the last second is, well, here, remember that negative 1 and 1 are still restrictions on this equation, but neither of my answers were negative 1 or 1. So both of these answers are valid for this rational equation. Okay, that's it for this one.